Hello guys, welcome to this channel. Today we'll be talking about indices and logarithm. Indices and logarithm. So if you are just joining us in this channel, we educate ourselves on topics on mathematics topics. So if you are just joining, please click on the subscribe button and turn on the notification bell so that by the time we are dropping videos like this, you'll be the first person to get notified. So today we are talking about indices and logarithm. And on this particular topic, we first look at the concept. Then after the concept, we look at how we can simplify indices problem. Then we move to how we can solve indical equation. Then we'll now talk about logarithm. So the concept of indices, like you've seen on the board, 2 raised to power 5 is the same thing as 2 multiply itself 5 times, and the value is 32. So you have 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So the value, this is the value of 2 raised to power 5. This is the expanded form, while this is the index form. So you have 2 as the base, while 5 is the power or the index. 2 is the base, 5 is the power or the index. We also have an index, a raised to power 3. It's the same thing as a times a times a. So a is the base, while 3 is the power. So let's look at the laws. The laws of indices. Laws of indices. So you have, first one we have a raised to power of m times a raised to power of n is the same thing as a raised to power of m plus n. A raised to power of m multiplied, when these two index of the same base multiply themselves, the product, the simplified form, is equals to a raised to power of the sum of their parts. Yeah. So in case you have, for example, you have 2 raised to power of 5 multiplied by 2 raised to power of 3, which is the same thing as 2 raised to power of 5 plus 3. Hope you get that. That would be 2 raised to power of 8. And 2 raised to power of 8 is still the same thing as 128. 2 raised to power of 8 is still the same thing as 128. So 2, we have a raised to power of m divided by a raised to power of n is the same thing as a raised to power of m minus n. And see now, when two index base a, the same base, under division operation, you have their power to be subtracted. You subtract the power of the divisor here from that of the dividend. So you have, so in case you have something like 3 raised to power of 4 divided by 3 raised to power of 2, that gives you 3 raised to power of 4 minus 2. That will give you 3 raised to power of 2. I hope that is clear. So now the next we are talking about the laws of the indices. Third law we have a raised to power of m, then also all of it raised to power of n. This is a kind of law called the power law. Now this is a base a having raised to power of n, m. Then again it is raised to power of n. So this will be simplified as a raised to power of m multiplied by n. Are you getting it? So it will be a raised to power of m n. The powers will be multiplied. The product of the power. This is why in case you have 2 raised to power of 5, 2 raised to power of 5 multiplied by raised to power 4. That gives us 2 raised to power 5 times 4. 2 raised to power 5 times 4. That will give us 2 raised to power 20. I hope it's getting now. So that is it. That is power law. Now we have the next law 4. A raised to power of 0 is equals to 1. This is called zero law. Zero law. Anything in indices raised to power 0 is 1. Anything raised to power of 0 is 1. Also, we have 1000. 1000 raised to power 0. That's equals to 1. So in indices, anything raised to power 0 is 1. Now, the fifth one, we have a raised to power minus m. A negative power. Minus m can be any number minus 5, any number whatsoever. So this base is raised to a negative power. This will be the same thing as 1 over a raised to power m plus m. Do you get it now? You'll be able to turn it to fraction. 1 over a raised to power m is the same thing as a raised to power minus m. So if you have something given to you 2 raised to power minus 3, and you are looking for the equivalent, or it's the same thing as 1 over 2 raised to power 3. 1 over 2 raised to power 3. And 2 raised to power 3 is 8. I'll give you 1 over 8. I'll give you 1 over 8. I'll cut it now. So we are still on the laws of indices, and now we want to talk about fractional index. Fractional index law. Now, before I continue, please click on the subscribe button so that you turn on the notification bell and share it with your friends and your friends and loved ones, so that they can be benefit if you are getting value from the video. So now we want to look at fractional law. First thing is we have a raised to power 1 over 2. A raised to power 1 over 2. That is the same thing as the square root of a. A raised to power 1 over 2. A is the base is raised to a fraction 1 over 2. That is the same thing as a, the square root of a. So the root number is the number of the denominator here. Like for example, if you have 4 raised to power of 1 over 2 is the same thing as square root of 4. And you know that the square root of 4 is 2. So now, similarly, we have a raised to power of 1 over 3. That is the same thing as the third root of a. A raised to power 1 over 3. The same thing as the third root. Denominator is the number of the roots. We have a third root because the denominator here 1 over 3. The denominator here is 3. So that is, in case you have 8 raised to power of 1 over 3. 8 raised to power of 1 over 3. That's the same thing as the third root of 8. I know that the third root of 8 is 2. So and so on. But in case if your denominator or numerator of your base is not 1, you have 2 over 3. A raised to power 2 over 3. In this case, the numerator is 2, not 1. And the denominator of the fraction is 3. So this will be third root of a, all raised to power 2. Can you see? So you are raising it to power 2 because your numerator here is raised to power is 2. So if you have 8 raised to power 2 over 3, this will give us the third root of 8 all raised to power 2. I know the third root of 8 is 2. So you raise it to power 2. That will give you answer to the 4. So in general, if you are dealing with fractional indices, you have fractional indices. Now, if you have an index to be simplified, 27 raised to power minus 2 over 3, then this kind of simplification, firstly you need to apply a negative rule to it. The base here is 27. The base is 27. So for you to take away or eliminate the minus, get rid of the minus, you have to take the reciprocal of the base. And when I say reciprocal 27, the reciprocal of 27 will be 1 over 27. So if you have taken the reciprocal of the base now, the reciprocal of 27 is 1 over 27. Then you can now get rid of the minus. You have 2 over 3, right? Now, you have gotten rid of the minus, you can now apply fractional index law to it. That will give you the third root of 1 over 27, all raised to power of 2. So, third root of 1 is 1, and third root of 27 is 3. When you multiply it by raised to power 2, you have your answer to be 1 over 9. I hope you understand that. So that is on fractional index. So we can say in general now, a raised to power n over m. N over m is a fraction. So it's the same thing as the nth root, mth root, because the denominator here is m, base root a, mth root of a multiplied by n. So that's the general form of fractional indices. So now we're going to be looking at how we can solve the indical equation. When we say indical equation is an equation that deals with indices, that relate with indices. Equations that relate with indices. Now, for example, they ask us to solve. They ask us to solve the first one, 1 over 2 raised to power x. They told us is equal to 8. And you know, we've already seen, when you see an equation, you know by the equality sign here. This equality sign. So every equation has two sides, the left hand side of the equation and the right hand side of the equation. So on the right hand side there we have 8, while on the left hand side we have an index of base 1 over 2 equals to x. So we'll be looking at how we can equate this. This is telling us the base on the left is 2, which is a fraction. So I can express it as 2 raised to the power of minus x. Where am I getting the minus from? Because it's a fraction. Remember the negative index law. The x here is positive power. So this is 1 over 2. Reciprocal of 1 over 2 is 2. So, and which is equal to 8. So what is on the left hand side there is 2. And what is on the right hand side is a value 8. So you need to express this in index form. So you express it as 2 raised to power minus x is equals to 2 raised to power 3, because 8 is the same thing as 2 raised to power 3. 8 is the same thing as 2 raised to power 3. So if the base on the left and the right are the same, you can make the power to be equal to. So you have minus x is equals to 3. So in this case, you are not looking for minus x, rather you are looking for x. So how do you eliminate the minus? You can multiply the whole of the equation with minus. So this one will become plus, minus and minus, and this one will be minus and plus, which will be minus. So that's how we got our answer to be -3. So, okay, I also solve another equation for us on the board. This thing, okay. I will solve another equation. We have 3 into 3 raised to power x. 3 into 3 raised to power s is equals to 27. Now look at what is on the left hand side here, and this is equation. The left hand side is 3 multiplied by 3 raised to power s equals to 27. There are many ways of doing it. You can express this as 3 raised to power 1, because this is obviously raised to power 1, and you show the multiplication as 3 raised to power x equals to 3 raised to power 3. 27 is the same thing as 3 raised to power 3, right? So 3 raised to power 3 is the same thing as 27 times 3 raised to power x 1 equals to 3 raised to power 3, right? So on the left hand side here, you have product multiplication operation here that you need to deal with. So you apply your first law that says when the base are the same, 3 base 3, you add the power. So you have 3 raised to power 1 plus x. 3 raised to power 1 plus x. And 3 raised to power 1 plus x is equal to 3 raised to power 3. Now what is on the right is 3. The base are the same. So I can eliminate the base and equate the power. So you have 1 plus x is equals to 3. So 1 plus x equals to 3, and you are looking for x. You transfer the 1 to the right. So when you transfer the 1 to the right, you have x is equals to 3 minus 1. S is equals to 3 minus 1. S is equals to 2.